the list of attendees. You hear me well?
Recording has started.
Okay. Good morning, everybody. My name is Alenka Burja. I'm working at the Umanotera Sustainability Foundation in Slovenia, and we are one of the many partners in GPP 2020 project. And today I will be coordinating this very interesting webinar. Thank you to all of you.
Sorry, I can't hear you. Words are coming cutted.
I'll try again. I start again. Welcome to all of you at this webinar. I am coordinating it today, and I'm coming from Umanotera, which is organization on sustainable development in Slovenia, and we are one of the partners in this project. Thank you all speakers and of course all attendees. First I will quickly present you GPP 2020 project. It will not take that much time. And then I will present you the agenda, also speakers, and also house rules, how to cooperate today with speakers. So let's do it. Let's speak about the project a bit. So what was the starting point for GPP 2020? It was awareness that actually there is a lot of GPP examples out there, but there is not so much quantified information about the impacts of these projects or tenders. So the approach of GPP 2020 was twofold. First one was to make a lot of GPP or SPP tenders in order to have a big impact, and because there is 8 EU member states involved in this project, so altogether 16 partners, this was quite easy to achieve. But on the other side, we also wanted to quantify all these impacts, showing the CO2 and energy savings. So how did we do it? We actually compared results from the GPP 2020 low carbon tender with the one in the same field of the subject matter, of course, of the previous or the last tender or standard product tender. While comparing these results, we use LCC approach, but still focusing only to the energy-related emissions. So, and also these calculations provides approximate estimations of the saving achieved. So let's say it's a bit more simplified tool, not really looking to the all stages of the cycle, but mainly to energy part. During the GPP project, there were 4 calculators developed. They are all online, and also from February now, they are also all recorded in video. So it's very good educational tool that gives you help step by step how to do this calculation.
Can you please be a little bit louder, because I can't hear you clear again.
So they are calculators are vehicles, ICT, street lighting, and energy performance contracting. What are expected impacts from or results from this from our project? There is over 100 SPP, GPP, low carbon tenders for energy-related products and services finalized, and all results are documented in tender models that are published on the website. Then we estimated to gain up to 1 million tons of CO2 equivalent savings. And also during these 3 years there were a lot of support, so-called support activities in each country carried out, and this relates either to trainings, help desks, websites, networking, national events, and any other kind of information regarding GPP and low carbon tenders. Here just present some examples of these tender models. They are template. They present the main approach in the green tender and also give you calculation results of CO2 and energy savings. Here are some latest tender examples, and you can see that savings varies quite high, so there can be some 10,000 tons of CO2 equivalent savings, or only some 100 tons. It depends on of course, on the product or service. And here are some contacts. First website, then email if you have any additional question, and of course also all the partners who are involved in this project. So this very shortly about the project itself. We had in the past several webinars on very different products and service groups, and they are all published on the website, and some of them also recorded, so you are invited to have a look at them. And now let's go to our today task. So we have a low carbon street lighting solutions webinar. We have 3 speakers, and I will shortly present each of them. And I would also like to tell you how we will manage today's webinar. We propose that after each speaker, you have opportunity to pose any question or comments or whatever you would like, so to participate in. And you can do this on 2 ways. Either you raise a hand, you can see on the right side of your screen below participants or panelist list, you have a hand, so you click on it, and I will see you, and I will give you, or host will give you, possibility to speak. Or you can use a chat, which is on the top of the right part of the screen, and you can write down your question, which can be also during the presentation, and then after, when presentation will be ended, I can read it and ask the speaker to provide an answer. So our speakers are all experts in the field. First, Andrej Mohar is working on the field of light pollution for many years now, on the national and international level. Perhaps the most, there are 2 important things to say about him. One is that he was a founder or co-founder of the Dark Sky Slovenia organization, and also that he was a leader of the negotiation team in Slovenia, who in 2007 succeeded to adopt a Slovenian regulation on limiting values of light pollution, which is the only such kind in all member states. And I think this is a very successful work. And he will present us in general some data about lighting pollution and also lighting solutions. And very briefly also one of the projects in Slovenia about street lighting. Secondly, Jelena Kremenjas is a project coordinator at the United Nations Development Croatia. She is experienced project manager in the field of energy efficiency, renewable energy sources, and also sustainable development and international project management. So very welcome on the board, but UNDP Croatia is also a partner of the GPP 20 project. And then we have two speakers from Germany, Sabine and Andreas Hänel. And I know some, I can give you some information for Andreas. Dr. Andreas is a physicist and astronomer, and he is director at the planetarium in the museum am Schöllerberg, if I pronounce it well, in Osnabrück. But he's also working on the field of light pollution for 20 years and gained also some awards for his work. So we have very distinguished speakers here, and I would like to give a floor to the first one. And meanwhile, when Andrej Mohar will prepare his presentation, or start to prepare his presentation, just when one additional information, in next 2 days. In 2 days there will be another webinar prepared by Covenant of Mayors. So if you are interested, please go and listen also or participate in this webinar. Thank you for now. Now I give the floor to Andrej.
Good morning, everybody. Do you hear me? Can you see my presentation?
We can hear you, but we don't see your presentation.
You have to share your presentation with us, please. As discussed yesterday in the quick start, share application and do it, please. Thanks.
I don't have anything on the top of the screen for sharing this. I need some guidelines, please. My name is Andrej Mohar. I'm coming from dark sky Slovenia, and I have impossible task to present light pollution in 15 minutes. So we would need 2 days, but I will try to do my best to present, to get a feeling what light pollution is and where are the problems. Of course, I'm a big supporter of renewable energy, but on this screen you see a windmill near Munich, Germany, which is illuminated bottom up and makes a lot of light pollution. So low carbon, let's say, devices and let's say ideas does not necessarily help to reduce light pollution. On contrary, sometimes. And this is the problem that we face, and we do not think just about low carbon economy, but also other very dangerous impact on environment. So what's the problem? My hobby is astronomy, and I simply cannot find the, let's say, natural starry sky in Europe. Impossible to find it. Maybe somewhere high in the mountains, 3,000, 2,000 meters in the middle of Austria. Maybe there are few islands in the middle of the Mediterranean where you can see a natural, almost natural sky. But 99% of the area in Europe is heavily light polluted. On this screen, you can see fisheye images composed by two. On left side is from Austria, from the mountains, and on the right side is natural, typical rural sky in Europe. So our problem is that we simply cannot enjoy in night as it was, let's say, 50 or 100 years ago. It's not just a problem for us amateur astronomers. Professional astronomers, they face a huge light pollution. This is the largest continental astronomical observatory in Europe at Calar Alto in Spain. Very expensive plant, but you can see, because if it is cloudy, you can see much more light pollution. So the sky is bright, but should be completely dark. So the problem is that natural heritage is, night heritage is already lost. Our sky during the night becomes brighter and brighter, and most of the people cannot enjoy in natural heritage. What's the problem? The problem is that we cannot limit the light to, let's say, a few square meters. If we use improper lighting, light can reach 200 kilometers. So improper lighting in the cities on the left side on this screen can make light pollution up to 200 or even more kilometers. So the problem is that even in the city centers and in the towns, we should use fully shielded lighting. So the lighting that illuminates just streets and pavements and nothing else. Otherwise, we simply introduce too much light in the environment, and we simply cannot stop growing light pollution. So the only way to preserve parks is not to have no lighting in, let's say, parks, but simply to care about each lamp in cities and towns. So Slovenia has adopted in August 2007 perhaps the most advanced light pollution legislation in our planet. So it's similar to Lombardy law, but Slovenia is still the only country. After, let's say, 8 years, we are still the only country in the world with relatively effective light pollution. And such lamps, which are very common in Europe, are not allowed anymore in Slovenia. For example, the lamp, which is flood lamp coming from the floor up, it's 100% waste of energy, 100% waste of carbon. This is total nonsense. But such floodlights, for example, they are sold in millions each year in Europe. In Slovenia, this is not the case. It's not allowed anymore. So somehow we are on the safe side. But we have another problems. We have a problems that industry invented very efficient LED lighting, and we use simply too much light, much more than it's necessary. So the problem is not because the light pollution is very, let's say, strong in this moment, but what will happen in next years. So our measurements at Črni Vrh Observatory in Slovenia during the last 15 years before adoption of the light pollution law showed about 8% annual increase of light pollution. How it is in other European countries, they are different, but in most countries we can measure increase of light pollution. And what's happened if there's 8% annual growth? Here's a graph that can show that in 2050, if we continue with 8% growth, it will be 2,500% increase of light pollution. Okay, not in every country is so bad situation, but in general, light pollution is growing problem, and we simply don't have any tool how to stop it. we simply don't have any tool how to stop it. We know how to stop it technically, but simply industry is not interested in reducing amount of new installations, or simply industry is absolutely not connected with environmentalists, and these are two words, and we have to change the situation. Otherwise, we will face huge problems in next years. The main problem that affects almost everybody is that bedrooms are too illuminated. If it's necessary due to health reasons to sleep in total darkness. This means total darkness means less light at its full moon. So it must be really dark that we cannot see anything in our bedroom. But situation is completely different, and the problem of modern people is that we are inside the offices during the day. In fact, in a very dark, we are not exposed enough during the daytime to the light, and we are very heavily illuminated in evening time, and also during night time we do not sleep in total darkness, and such problems could have big effects on health. It can disrupt circadian rhythm, our circadian rhythm, because melatonin is not produced during the night time if we are exposed to the light, and if we have a low melatonin hormone, melatonin is so-called sleep hormone, then in a longer period of time, people could have, let's say, more breast cancer or prostate cancer. They are more nervous, they get more fat, they are exposed to diabetes and so on. So health issues are extremely important, but we simply don't have time to go more detail into that. What's the problem? The problem is that new, very efficient LED lamps emits a lot of blue light, and blue light just disturbs circadian rhythm. Disturb melatonin production in our body, and we can see on this page that the blue peak is exactly at the same wavelength, whereas the highest sensitivity, circadian sensitivity in the human and also in animals. So this is a huge problem, and we simply don't know what will happen, but consequences could not be in a short period in time, but we could see them in 5, 10, 15 years. So the next problem is biodiversity. For me, biodiversity loss is even more important than carbon emissions. Why? Okay, carbon emissions, yes, we understand them. Increased temperature, 1 degree, 2 degrees, a lot of problems, but still biodiversity, we simply don't know what will happen if we could eliminate, for example, night butterflies, moths, 99%. So there could be big influences on nature in general. So moths are very affected with by lighting, especially white light, which is very popular in last years. Then birds are disturbed, mostly during migration. Bats are very disturbed. Sea turtles are affected. And fifth point, prey-predator relationship. So the night sky, it's every year more.
Hello?
Andrej, can you hear me?
Hello, everybody. This is Jelena Kremenjas from United Development Croatia. As already introduced by Alenka, I've been working at UNDP for 8 years, mostly on energy efficiency national projects, which was implemented in all cities and counties in Croatia. It was a nice time to introduce energy efficiency in Croatian municipalities. And regarding that, today we are implementing GPP 2020 projects within 18 national procurement bodies, mostly big companies or big municipalities.
Jelena, sorry?
Yes?
A bit closer to the microphone, but please.
Okay, I'm sorry. One of the most interesting and, to be honest, the easiest case studies and tender models was the one that was implemented by municipality of Župa Dubrovačka. A little bit about municipality Župa Dubrovačka. It's situated down south. So maybe if you want to see it in person, in June or July, we can organize a visit to Župa Dubrovačka because it's situated in Dubrovačka County, which is the southern point of Croatia, at the coast. So it's a coastal town, small coastal town, about 23 kilometers, and it has population of about 8,000 people. Their budget in 2015 was 11 million euros. So you can see from this that that's not a big municipality. What they did is actually they started as introducing a SAP, Sustainable Energy Action Plan, and that gave them idea to develop their actions more. So that's why they decided to go with GPP procedure. We did with them also procurement of electricity. So being such a small municipality and having such a big result is actually the light example for Croatian municipalities. Their approach was to, first of all, to make roads safe. That was their goal. With that goal, they wanted to, besides to have safe roads and normal traffic flow, they wanted to be more energy efficient. They wanted to protect environment, and they understood from what we told them, they understood benefits of energy efficiency. This is very important actually because political decisions are the ones that will make changes. So when it comes to public bodies, local governments, without assuring a political decision, none of the projects will ever have any success. So maybe our approach is a little bit longer, but what we're making is that once we assure political decision and political involvement from local governments, then we know that whatever we will do by the time that when it will end, such as this project, we are assuring sustainability. We know that they will continue with the procedures that were implemented while we were present in actions with them. This approach was, of course, to improve the quality of street lighting, and to be honest, it's always about cost. So they wanted to save money, but at the same time to do some good things such as environmental protection and safety. So they published an open tender for replacement. So it wasn't new. It wasn't new roads. It wasn't new lighting. It was a replacement of existing street lights. In order, of course, to emit less light pollution, but this is something that Andrej was explaining more in details. It was a very nice presentation. but definitely he can tell more about pollution than I can. But I can talk about greenhouse emissions, which is, you're going to see that in next slide. I'm sorry, this is to repeat. So by changing to a LED lighting system, municipality reduced energy consumption. Later you will see the percentage of their savings. What they did is they replaced high pressure mercury lamps with LED lamps. This calculation, later on that you will see, was based on 686 LED lamps. So they had 686 high pressure mercury lamps, and they switched it to LED.
Jelena?
Yes?
Louder, please. Closer to the microphone. Thanks.
Yes. The technology that has been used, of course, was programmed such as the lamps can switch to different mode once the visibility is reached. So it's kind of controlled by illumination and the intensity of light, which also is important thing when you want to save energy. When we did specification and tender model, besides the lamps, you have to make sure other things are in place as well. So we also, as a part of this tender model, was a supply and transport of tines, power cables, other things that are important in order so you can make, so you can replace these lamps. In total, every single line here had its own technical specification. I'm not sure that you will understand, but this is what we did is this actually. Sorry, I will change. My new. Can you see this?
Yes.
So all data had its own specifications. So when it comes to supply and transport of standard tine, it's described by 60 millimeters, the length, the angle, etc., etc., guarantee 10 years. All this has its own specification, including, of course, light bulbs, the color, and the intensity of light. Savings are here shown. So comparing to previous consumption, which was 330,000 kilowatt hours, emitting 100 tons of CO2 emissions, with new LED lighting today, this municipality uses 210 kilowatt hours, 1,000 of kilowatt hours per year, and emits 64 tons of CO2 emissions. This is a 36% reduction comparing to a previous situation. And when it comes to financial savings, it's almost 40,000 euros a year. So this money can be reinvested in other things that will also in the future save money and energy. Annual savings are 36 tons CO2 emissions per year and energy consumption 10 tons of energy per year. In total, in lifetime savings, that's 900 tons of CO2 emissions and 250 tons of energy. Other technical specification regarding the bulbs were like color rendering index, color temperature, which is in kelvins, of course, other things that were important in technical meaning. This technical specification doesn't mean that can be or will be used in other municipalities which have maybe more light. So these technical specifications can be changed, and of course, we did some research and lots of analysis before we made an approach to which technology we are suggesting them to switch to. I hope this helps. I don't know if I had to be longer or shorter, but for any questions, I'm here to answer.
Thank you, Jelena. I would suggest first that if there is somebody having some direct question for Jelena, to speak now. Yes, please. Hands out. Question sent. No. If not,
Harald. I think Harald raised the hand.
Please take a look at the attendees list, Alenka, and there you see who raised the hand.
Yeah, I didn't see it because it's just below my logo of the. Okay, Harald, to pose the question, please.
Yes, hello, but I cannot see me, or you cannot hear me.
We hear you, Harald.
Oh,
we
oh
hear
that's
you.
great. That's great. Yes, my question is, why do you not limit the amount of blue light coming out of the new LED installations to 3000 Kelvin or much lower?
I don't have at this moment answer to your question.
Okay, and another.
I will write it down and I will send you a written answer if that's okay with you.
Okay, and then
this model was from last year, so forgive me if I don't remember all the details.
Okay, and then another question is, did you calculate the carbon dioxide amount which is used to replace the LED elements after 200,000 of used hours?
No.
So you should, because this is a big impact. It's much more less resource needed to put in a new bulb, but it's much more resources needed to have a new LED element. And this needs to be calculated in such calculations. Otherwise, you may lose a main factor.
Okay, so your suggestion is to use what formula for calculation?
I do not have the formula here, but you need to calculate what are the costs to produce the new LED elements when you need to replace them.
Okay, I will take that into consideration. Thank you so much.
Perhaps just to add shortly to this suggestion, as I explained in the beginning, we use CO2 calculators, which are quite simplified, really looking to the use phase of the energy and CO2 impact. That's why perhaps also this very important, as I understand, impacts were not taken into account. It's not excuse, it's just these are just facts, because LCC calculators are really not easy tools. But thank you very much for your proposal. So we have two very valuable issues here. So replacements of LEDs and also luminarity of the LEDs. Thank you.
The comment was actually really good, but this should be implemented on the other side, because what we are dealing is actually with the consuming side. This aspect should be implemented in a phase where science has more influence than and consumption. So, but the comment is really good. Thank you so much.
Okay, thank you very much. I think looking to the whole life cycle cost, this is of course acceptable. I have another raised hand here. It's Lauren. So please go ahead.
Hello, can you hear me?
Yes, we can hear you.
Okay, great. I would have two short questions. On the one hand, I would like to know how the street lighting project was financed. It sounded to me like the upfront investments were directly paid from the municipality. Is that right?
It was a public procurement with the open procedure.
And it was not connected to anything like energy performance contracting?
No.
Okay.
It was procured with the status of work section.
Okay. And then my second question is actually directly connected to that. You mentioned that there's a 36% savings of energy consumption. To my perspective or experience, it sounds rather low to me for LED refurbishment. I think if you change street lighting, and especially if you control it with combine it with automation and a control system, you can easily reach between 60 to 80% reduction.
If you change the whole road, but this is just a partially changed, so we have to see the whole consumption. All lamps are still present in some parts of the municipality.
Okay, that makes sense. Okay, thanks.
You're welcome.
Thank you very much for these questions. Any other hands out? I would kindly ask you, Lauren, Harald, to switch off your hands, unless otherwise I will think that you still want to ask a question. Is this the case? Harald, do you want to ask another question?
Yes, I would like. Yes, I would like to ask. I would like to ask: is there any, or was there any financial support from European Union to make the projects, conversion projects? And what is the amount of money which flows from Brussels to Slovakia?
I don't know about Slovakia because
sorry.
From Croatia.
So Croatia. Sorry.
We have something which is called. We have a national fund called Energy Efficiency and Environmental Protection Fund, which is financing projects in energy efficiency and renewable energy related fields. Of 200 euros, this is value of this contract was 200 euros, excluding VAT. I think it was without the tax. 40% of it was financed by Energy Efficiency Fund. So it was supported by national financial instrument, which is the case for most of the projects in energy efficiency and environmental protection. The fund is financing from 40 up to 80%, depending on the area where the municipality is situated. So if it's under state concerned territory, which were affected by war 20 years ago, then you would be eligible for 80% of funds. If you are situated in islands, you are eligible in most cases for 80%. If you are in Zagreb, then you will get only 40%. So yes, all the projects that we are implementing rapidly are, in most of the cases, co-financed by Energy Efficiency National Fund. This is not money which was that we didn't apply with this to Brussels money. We just went to our national funds.
Okay. Thanks a lot. Some more questions? Harold, your hand is still up? Okay, I guess no. Very interesting topic indeed. Please, I would suggest that Andrej try to finalize his presentation, because we already have a question for him, and then we will see further how we stand. Andrej, how are you doing? So perhaps, Andreas, you could also already start to upload your presentation. And meanwhile, I will just let you know, because I just find out this information, that Sabine is a coordinator of the Dark Sky Reserve Biosphere in Rhön River area in the center of Germany, so quite important task. Working on the light pollution, of course. Can we have a presentation now?
That's the program finished. I can't, it's simply finished. I can't go in.
Okay, Alenka, can you load the presentation on your computer?
From the Andreas?
Yes.
Well, we would like to introduce our sustainable and energy-saving lighting in our dark sky reserve within the UNESCO Biosphere Reserve Rhön. And actually, it's Dr. Hänel who is the person who's got the most technical knowledge. And as you can hear, the church bells are starting to ring, but I will give it a go. I would need the next slide. Alenka? Can you hear me? Okay, thank you. Well, the situation is that we the Biosphere Reserve Rhön has got quite a high altitude. It is a biosphere reserve acknowledged by the UNESCO, and it is known for its biodiversity. The highest mountain within our mountain range is called Wasserkuppe, and it's world famous actually for gliders. Even Neil Armstrong has visited the Rhön or the Wasserkuppe because of gliding. After World War II, it was used mainly by the US military. And as you can see on the picture on the right-hand side, the military area was surrounded by lots of lights, which was quite good for the people because then they knew where the highest mountain was at night. In 1991, the Biosphere Reserve was acknowledged as Rhön. The Americans left the Wasserkuppe and the lights were put down. It is quite interesting for tourists to visit the Wasserkuppe for many reasons. There's gliding, there's hang gliding, there is paragliding and all these things. And lots of tourists visit that every year. I would need the next slide, or if Andreas is back, he can.
Yeah, I'm back.
Okay.
Can you hear me?
Yeah, I can hear you. I think from now on, this suits quite well. You are able to take over. Just one more sentence. The situation was that a couple of years ago there was no street light at all, and a couple of years ago the police decided we need to install street light there. The reason was, they said, because of security, and behind that was the problem that they improved the roads, and they thought more roads, more traffic, more light is being needed, and that was the original situation. Andreas, I think now it's your go.
Okay. You can hear me?
I can hear you.
Or can you hear me?
Yes, we can hear you, Andreas.
Okay, so I'll continue with this. Thank you, Sabine, that you started, but Sabine really was the main person in this project. Well, as she told, the idea was to develop the Wasserkuppe touristically and to make new parking places, new streets, and they had to install lighting. The installed lighting that was there was high pressure mercury, just 4 lamps at 125 watts, so totally 500 watts. They were on all the night, so they consumed per year about 2,000 kilowatt hours, and this is equivalent of about 1,200 CO2. You see the plan, and you see for the modification, and I've encircled there in green the 4 lamps that have been installed. Could you please go to the next slide? Yeah, thank you. So it was especially Mathias Hahner from the Rhön Energie who made the planning, and the first initial planning was just conventional planning using 18 luminaires, and these were LED luminaires, but already with a color temperature of 3000 Kelvin. And they had also to be full cutoff, so lighting class G6. That means that no light will be emitted above the horizontal. The initial planning was already to reduce lighting by 50% between 10:30 in the evening and 5:30 in the morning. So the total energy consumption would have been 2,500 kilowatt hours. So it's a little bit more than before, but we have instead of 4, 18 luminaires. Next slide, please. Well, and then, as Sabine told, the UNESCO Biosphere Reserve Rhön applied for the status of an International Dark Sky Reserve. That's a designation by the International Dark Sky Association. And finally, in 2014, it was designed. And within these, within the designation, we made some lighting guidelines to reduce light pollution, but not only to reduce light pollution, because in the dark sky parks, we want not only conserve the dark areas, but we want also to give good examples for sustainable lighting. So this means we have to use full cutoff luminaires. We have to reduce the blue spectral parts in the blue spectral parts of the light. We have to reduce the luminous flux during the night when there are less people. Better would be to have an adaptive, intelligent lighting according to the needs, and not only energy efficiency, but also to be in complement to the nature. So a new tender was made with no blue light content, and the proposals from several firms for the tender were to use yellow filters to reduce the blue, to use either PC amber or amber LEDs, and to do the reduction during the night. You see here, these are our lighting guidelines. They are on the internet, but only in German. But if you go to the International Dark Sky Association, you find also English versions of this. The next slide, please. So why reduce blue spectral parts? I think Andrej wanted to talk about, or he started to talk about this, so I only made it very, very shortly. I think one of the most important things with using blue in white light is that you have less glare. It's one thing we remark in many, many cities in Europe now and also in the US, that the citizens are not very content with the new LED lighting because it is very glary. So if you use warm white LEDs, it's less glaring. It reduces the detection of insects. It has less scattering in the atmosphere. With yellow light, you have better transmission if you have a lot of haze or fog, and you have less influence on circadian rhythm that was Andrej talking about. But if you take monochromatic yellow lighting, you know it from low pressure sodium lamps, they have a reduced color recognition, and you can change it quite easily if you put about 10% of blue light to it. That was already known with the sodium low pressure luminaires, and we choose here something of a mixture of different LED lights. So the whole thing, the decision of this was a cooperation between the Landkreis Fulda, that's the county that is responsible for the Wasserkuppe. Sabine is working for this county. It is the city of Gersfeld that is responsible for the Wasserkuppe, the police, because they wanted to have more security, and finally, of course, the energy supplier who made all this technically, that's the Rhön Energie in Fulda. And you see here the spectrum from Harald, who has just talked. He has taken a spectrum of the final decision for the luminous. You see there in red, that's the so-called bad lamp. That's a monochromatic yellow. It's more or less the same like sodium low pressure. And then the spectrum of the golden orange, they see some addition of blue and yellow light so that you have better color recognition. Next slide, please. So there was a revised planning, and it was one really looked how many luminaires are really necessary. So at the end, it were only 13 luminaires. The total luminous flux was reduced to 26%, and the installed power was also reduced to 430 watts. So it has been halved. And the power consumption, if the lighting would have been switched on all the night, would have been 1,800 kilowatt hours. The solution were 10 so-called bad lamps with amber LEDs and 3 golden orange with a mixture. Both have a color temperature, correlated color temperature of about 1,800 Kelvin. Next slide, please. Here you see the example of the bad lamp that is used here. You see passage for passengers, crossover, and you see, if you look at the left picture, that these luminaires are very, very well designed, that they are not very glary. So we have an illuminance of about 9 lux. That's okay for this region. And in the next picture, you see the golden. The next slide, please. You see the golden orange. Next slide, please, Alenka.
Alenka, we need the next slide.
Yeah. Okay, the next slide, thank you. Here you see the golden orange. That's a mixture of amber, red, green, and warm white LED. So you have a little bit more efficiency, and if you look, you get an illuminance of 6 lux. That's at the bus stop where they want to have a better color recognition. And if you have the next slide, please. Here you see, unfortunately, I had the spectrum again, and unfortunately, I had no color table, the normal color table, but I just used my Plantam program. And then you see that with the golden orange, you can distinguish quite well colors where the bad lamp is only monochromatic light, but it's sufficient to see the contrasts, to see passengers crossing the street, and so on. And in the next slide, you see that now a very intelligent adaptive lighting has been applied. So you see, when there are fewer people, and during night there are only very, very few people, or nearly no people, only astronomers that are there. So they reduce lighting in the evening at 7 o'clock in the evening by 50%, 1 hour later to 30%, and after 9 in the evening it's switched off. Only if there are special events at the Wasserkuppe, and we have them in summertime, then the lighting keeps on till perhaps midnight. It just depends on the event. So it is a very intelligent adaptive lighting. And by this possibility by using this, and that's in the next slide, we can reduce energy consumption considerably. So you see the power consumption is only 324 kilowatt hours. Before it has been with other solution, it would have been 2,500 kilowatt hours. So it's an energy saving of around 10%, depending if you take the already reduced before the first idea, or if you take the full lighting, so you have 8.8% if you would have kept on the LED that was already LED lighting the whole night, or you reduce it. So you see, with a very intelligent adaptive lighting, you can really you can reduce energy consumption, but you have also an environmental friendly lighting. And this is a good example for the other communities in the Rhön. We have more and more communities in the Rhön that use now 3000 Kelvin. You see on the left side a test road of Rhön Energy. They only use 3000 Kelvin or lower, you see in the red one. And they also reduce the light during night, and we know from one city that has reduced the energy consumption to 30% they had before. And the other thing is that by this example we also could influence the German firms, and we now have at least 2 German firms that now offer amber LED lighting, because many communities by this way can exchange the sodium high pressure lights that they used before by these amber lightings, so that they have this warm color in the streets they use. That this is very good. And just to say, because there's always this controversy between 3000 and 4000 Kelvin. Yes, 4000 Kelvin LED lighting is a little bit, perhaps 10% more energy efficient than 3000 Kelvin. But if you use intelligent lighting that is adapted to the needs of the people, you can preserve much more energy, and of course CO2. And the next slide, by this way you have a very nice night sky. I think that's the most important, and thank you very much for listening, and I wait for questions.
Thank you very much. Very useful information. Perhaps I would ask Lauren to pose the question, because he brought one question. Lauren, can you do it? And it's related to the industry and also to the presentation of the Andrej Mohar. But let's first go for questions. Okay, first it's Harold.
Yes, hello. Hello, this is me. This is Harold. Can you hear me?
Yes.
Yeah, okay. Andreas, I do have one question. Or could you please mention the names of the companies which offer those nice blue-less lamps? Others should know that these companies are waiting for invoices or or questions.
I don't know if I can do it, but
I can do it.
Well, pardon?
I can do it if you don't want to do it.
Yeah, I can do it, of course. So the installation was made by a Dutch firm. It was no German firm, because no German firm could offer it to us. So it was made by a Dutch firm that's called Illumination. So it's now a Belgian firm, Illumination, and the 2 German firms are 2 of the largest German firms. That's Trilux and Citeco. And we know also that Philips can offer that these luminaires.
Okay, thank you. So there's enough choices to get those lamps.
Yeah.
So there's no excuse not to use them anymore, is it?
exactly, that's what we think. The thing is, at the moment, what we see everywhere is that the communities, all what they think of is energy efficiency. That's the only argument, but they forget other environmental aspects, like, as we always say, the blue content in the light, which just has got nothing to do in the night. We have to really reduce blue light content at night. But in the discussion about energy efficiency, this aspect is just not considered. And this is what we try. So we try to convince people it's not only energy efficiency we have to look at, it's also that the light is environmentally friendly, and this can only be done if the blue content is reduced.
May I add something? Because if what I just told, if you see in many cities that they have to start to replace their cold white lighting because citizens are not content with this, then it was not a sustainable investment to put their just LED lights. We think it's better to put warm white LED lighting because people do like it more, and it's also doesn't influence so much nature.
Exactly. Yeah.
Yes, I would like to, then I will read the question that Lauren posed after the presentation, not finished presentation of Andrej, but it's related to these issues that we are talking about. And he wrote, I would like to comment on the topic that industry is not interested in reducing amount of light installation. Isn't that an issue of consumption and unreflected procurement? And actually this is what you have also been saying just right now, that industry will respond on the demand of the either consumers or public authorities, right?
Andreas?
Yeah, yes, that's what at least in Germany we hear from the industry, that they respond to what the customers want. But the customers are often not very well trained in lighting, so they have to rely on the information they get from the industry often. And the industry wants to sell what they have done all the time. Yeah. So I think, and I think it's also the aim of our dark sky associations to inform the public what is good, in our opinion, the good lighting, and that the public, and that's what I'm doing in consulting, for instance, communities and other people, to convince them what is, in our opinion, a good lighting, that they can go to the industry and then say, we want to have this and this lighting for the industry. It's no problem to make another LED. They can do it, but the customers must ask for it. And I think that is what we see now, that there is something changing in the industry. Because I remember when 5 years ago I said to the industry, we should have 3000 Kelvin LEDs. They were more expensive. They were at this time less energy efficient. That's true, but this has changed now. Now nearly every firm offers 3000 Kelvin at the same price than 4,000 or 5,000 Kelvin. That's no problem.
Yes, okay, there is a question from Hans Moons. Can you speak, please? Ask directly, or should I read it? Please go ahead. Hans? Ah, okay, he has no microphone. The question is, what about the cost of warm white LEDs? Is it similar to the cold white LEDs, or are the warm white light LEDs still more expensive?
No.
Does somebody knows to answer the question?
I just answered it. I say they now offer 3000 Kelvin at the same price than 4,000 or 5,000 Kelvin. There is no there is no price difference.
There's no difference, no.
Okay.
If I may add, our local energy supplier who we managed the project with, the Rhön Energy, which is quite a big energy supplier in this area, they definitely say there is no price difference. This is just a myth or just an old idea, and that it is more expensive. It is not, definitely not.
Okay.
It really depends what kind of which manufacturer you choose. Yeah.
Yeah. Okay. One of possibilities to give more information and knowledge and awareness to procurers and consumers is also the revision of the existing street lighting GPP criteria that is taken part now at the EU level, Commission level. We are now going to the closing time, so I would like to ask Andrej Mohar, because he did not finalize his presentation, and I'm afraid we will not have time to do it, to listen to all his presentation, but it will be published on the website. If it's possible, he gives us some main points from his presentation, or main points regarding the presentations of the others and raised questions, so that we can conclude in this way. Would this be okay with you, Andrej? Andrej? Andrej, we do not hear you. Perhaps there are some other. Perhaps there is some other questions you still have. And I just got a message from Hans Moons, because he is from Joint Research Center from Seville, who is working on the revision of street lighting. And he sent Andrej Mohar, now we can see you on video, but we cannot hear you. He just sent us a link where everybody can register if want to participate in this revision process. But it's also on the website of EU GPP, so you can register there as well. Andrej, how are you doing? Interesting. We really do not hear you. Okay, I ask then other participants, attendees, still some questions to go on? Okay.
There's one hand raised from Lauren.
There is one hand, yes. Lauren, please go ahead.
Yes, hello. I hope you can hear me. Great. I was just wondering and wanted to raise a question for the whole audience. We talked now, or heard a lot about rather like technical specifications and how procurers can demand the right lighting specifications. But I'm wondering if there are also probably thoughts in the procurement process to change the whole business model aspect for lighting solutions. There was the point raised that industry is only interested in selling more and more light products, which is probably true because also procurers are just procuring lighting as a physical product, and they are not really procuring solutions for the municipalities. And I think that there business models like energy performance contracting actually coming up, where companies are starting to take over responsibility for the use phase of the product that they are delivering to their customers. So and I think municipalities can probably benefit from it when manufacturers stay in responsibility during the use phase. And I wanted to know if there are any experiences with that among the audience.
Very good question. So if anybody have some experience, please let us know. But what I know from the reading, this is of course a close approach to the circular economy concept, and one of such examples that I read about is Philips doing such kind of service contract and providing the whole, not only lighting but also installation, so the whole set of lighting systems, and then only letting consumers to use it. But these are new, as you said, new business models, right? Okay, many hands up. Sorry, Andreas, I will try with Andrej now if it's working. Andrej? Andrej, no? Then Andreas, please, your hand is up.
Yeah, you see the example we mentioned is something like this, because we didn't contact directly the manufacturer, but it was Rhön Energy. So in Germany we have many of these former local suppliers of energy that make these contracts with the communities. What you mentioned, that's at least in Germany now quite common.
Okay, so I guess it's getting importance everywhere, but these are probably slow steps. But yeah, hopefully to see also some other developments in this area. I don't know. It's time to close up. Is there still any urgent question that you would like to raise? I see one hand there from Andrej. Andrej, you can communicate anytime you want, you wish, because we are expecting you, but it seems doesn't work. Any urgent questions? No, not really. Other than I have to conclude this gathering. I think it was very valuable, and that we learned some of the main issues on what we have to pay attention when working with the procurers, because this is very true that many public authorities are now in the position that they have to replace old lighting systems. So now is opportunity to do a lot of changes. So then I thank you very much for participation and participating. Thank you very much all the speakers. And I hope to see you or hear to you again soon, somewhere. Okay, bye-bye.
Bye-bye.